Alright guys, so let us go through these questions, right? So we'll start with this first one here. Alright, so they said that they want to sketch the spectrum and also a way to convert it to trigonometric form and the complex form at the Fourier series, right? So we'll start with this one. So we already have these and something you had to remember, especially when you're doing Fourier, is the trig forms. So you have the trig form, a naught and 2 plus the sum k is equal to 1 to infinity ak cos, ak always goes with cos, and 2 pi k f naught t, plus sum k is equal to 1 to infinity bk sine, bk always goes with sine, 2 pi k f naught t. Right, this is very important. A second form is the complex exponential form, which is just the sum k is equal to 1 to infinity x k, e to the j 2 pi k f naught t, and the last form, which is the harmonic form, which is a naught and 2 plus the sum k is equal to 1 to infinity ck cos 2 pi k f naught t plus theta k. All right, so make sure you know these three forms because it will come back to one to in the end. All right, so we have this. So the first part of the question said to express it in its trigonometric form, right? So some things to remember, especially when you're doing spectrums, always make sure that the 2 pi is factorized on this side, always. Yeah, because these f's here will be what you call your harmonics, right? But you must make sure the 2 pi is always factorized. So what I mean by that is, if I had like say cos 8 pi f naught t, right? Right now, this is not in a form that you can extract the harmonics from it easily. So what you need to do is just factorize the 2 pi. So it'll be cos, pull out the 2, and the remainder you just spread back with the f naught. Yeah, so that's something to remember, right? So always make sure the 2 pi is factorized for you. Obviously, in this one, they already factorized for you, so you get through. Right? So that's something to keep in mind, right? Very important. Okay, so let's go through this. So with this question, you don't have to do much because it already is in the trigonometric form. Why? Because cos is already in cos form. Remember, the foundation of Fourier is expressing any signal into a sum of sinusoids. So the most basic sinusoids are cos and sine, and the trigonometric form, which is cos and sine, right? So it is already in the trigonometric form, right? So that's done, right? Even if it was sine at 2 pi f naught, it will already be in the trigonometric form, right? So that part done. The second part that I asked you is to express it in the complex exponential form. So clearly, right now we're not in the complex exponential form because in the complex form there is no cos to. So what we need to do is we need to convert the costs and the sines into exponentials, right? And something to remember is that cos theta, we want to express it in terms of exponential, will be e to the j theta plus e to the minus j theta all on 2, right? So that is how you convert it. And theta is literally everything inside the bracket. Yeah, so don't make it. So so now converting this, acting like this is theta, it would just end up being e to the j 2 pi f naught t, right? Plus e to the minus j 2 pi f naught t, and that is all on 2, right? And that is f of t. Right, to make it easy, that's could pull out the half. So f of t will equal to half e to the j 2 pi f naught t plus a half minus j to the 2 pi f naught t. Right, and just like that, it is in its complex exponential form, right? So you don't have to do anything else to it, right? That's the end of that piece there. All right, so that is this piece. And the last part of the question I wanted you to do is to plot the spectrum, right? So there's something to remember. When it comes to spectrum, they could ask two things. They could ask you for the double-sided spectrum, and look at axis with the single-sided. Right? So things to remember, anytime the axis with the double-sided, you must express the signal in its complex exponential form. So the complex exponential form will give you the double-sided, right? And for the single-sided, you need to express it in the harmonic form. Yeah, so the harmonic form will give you the single-sided, and double-sided, yeah, they express in the complex form to get it, right? So have a shortcut to go from the single-sided to the double-sided, but this is the general idea. So the double-sided spectrum comes from the complex form. So if you're in the complex form and you want to plot the spectrum, whether it's be magnitude or phase, you'll end up with a double-sided. And if you're in the harmonic form and you also plot the spectrum, it will only give you a single-sided. But there is a trick to go from the single-sided straight into the double-sided. So you'll do that in another video. All right, so for now, let's plot it. So we should know from now to have two types of spectrum, right? You have the phase spectrum, which is the angle part, and you have the magnitude spectrum. Right? The magnitude spectrum is basically just the magnitudes of the values itself. Right? So when you're plotting, it starts with the magnitude. So when you're plotting the magnitude spectrum, what the two things you need are obviously the magnitudes and you need the harmonics. Where you will get the harmonics? The harmonics is the F naught terms, right? After you factorize the 2 pi. Right? So in this case, it's only one sinusoid. So therefore, and when you factor the 2 pi, you end up with one F naught, or just F naught. So in this case, that is the only signal itself. Right? So in this case, your harmonics just go on the X, and your magnitudes of that specific harmonic goes on the Y. So this will be frequency, and this will be magnitude. Right? So when you go back to it now, there's one F naught. So F naught is called your fundamental frequency, right? So there's one F naught, right? And to get the actual magnitude of it, if it's in the trigonometric form, it's just the number before it, yeah? So in this case, it's 1, right? Remember, right now, this is in the trigonometric form, so it's not in the complex form, right? So if I plot in the single-sided, this will give me the single-sided, right? So I would say single-sided spectrum, right? The one F naught, it would just go up to 1. Yeah. And the phase is always the plus theta k part. In this case, there is no plus any angle, so it has no phase. All right, so the phase spectrum will just be empty basically. All right, so this is the single-sided spectrum, sorry. All right, so frequency still goes here, and on top here we'll have your phase. So the only harmonic we have is the one F naught, and there is no angle fit. All right, so this is the single-sided. All right, so let's do the double. So for the double, so for the magnitude, for the double, so you call this double-sided spectrum. So we had already expressed it in its complex form, right, which is this here. So from this, we could get the double-sided spectrum from it, right? So in this case, we have the same thing, but now it's double-sided. Where we get the double-sided from is for this term is one F naught, and for this term, because of the minus, it'll be minus F naught. So you end up with the frequencies going in a positive and in a negative direction. Hence where they get the double-sided from. So it's centered at 0, where you have in this direction and this direction. Yeah, so we have one F naught, which is from the first piece with the positive. You will always end up with a positive and a negative. Hence where they get the double-sided from. So this one here is your one F naught, And because of the minus here, you end up with minus F naught. So that will go on this side. All right. And the magnitudes for both of them are half. It'll always be symmetrical, right? So this will go up to a half, and this also will go up to a half, right? So obviously is magnitude, and the x-axis is frequency, right? So that's the magnitude spectrum plot, right? The phase spectrum, just as before, if you look at the complex exponential form, in this case, there are no phases, right? So the phase spectrum will again be empty. So same idea, it will be double-sided. So you have your 1 F naught and a minus 1 F naught, but it'll be empty. Right, so phase and frequency. Yeah, and with that said, that's the first question. Things to remember from this, make sure you know your true forms, right? Anytime you see something expressing cos and sine, make sure the factor is 2 pi, and it is already in a trigonometric form. To convert it to the exponential form, you have to convert the cos's. And if they had sines, you will have to convert the sines. So to convert the sine, sine theta is equal to e j theta minus e to the minus j theta all on 2i, right? So that's how we'll use it. But this is really used really because of the I, right? But just to keep in mind, but until we do harder questions for now, let's say one harmonic. It is in a trigonometric form because it is in the most basic form, cos's and sines. Cos and sine, not sines with a cos squared or anything, must be cos, right? To convert it to the trigonometric form, you need to convert those fundamental trigs into exponentials. So for cos theta, which is the most popular one that I will be converting, right, is e to the j theta plus e to the minus j theta on 2. Theta, as I said, is the thing inside the angle for the cos. You fling it in and you pull it out, and you end up with the complex exponential form. Yeah? And with that said, that is the first question, the spectrums. Right? So we'll continue more with the next video.